Hello friends, today we will solve some more questions on matrix algebra. This is the third video of the objective mathematics video series, and if you haven't seen them, their link is in the description. So let's start. So as you know, objective of this series is to help you guys preparing for the upcoming examinations, to cover all the topics of engineering mathematics in brief, and it will provide a quick revision of the subject, and you will be able to learn the basic things related to the topics. So let's see. Here it is saying if A equal to AB, this is a row matrix. A equal to AB, B is equal to minus B minus A, this is also a row matrix, and C equal to A minus A, this is a column matrix. Then it is asking which of the following is the correct statement. These are the options. So we have to check as per the options, we have to check which option is correct. So let's see, before solving this question, let's see what is matrix multiplication. If A is a matrix of order m cross n, suppose A is a matrix of order m cross n, and B is a matrix of order n cross p. B is a matrix of order n cross p. Here A is a matrix of order m cross n, means m rows and n columns. M rows and n columns. Similarly for B, it is n rows and p columns. Then the product AB is of order m cross p. M rows and p columns. So for example, A is equal to a 2 cross 3 matrix 2 minus 1 3 0 1 4, and B equal to 1 0 2 1 a 2 cross 2 matrix, and C is given as 1 0 2 1 minus 3 5 3 cross 2 matrix. Then we can say that A and B cannot be multiplied. What is the reason? Because let's see what is the column of A. Column of A is 3. What is the row of B? What is the number of rows of B? 2. So for matrix multiplication, the condition is the first matrix should have the same number of columns as the row of second matrix. So here you can see 3 is not equal to 2. So AB cannot be multiplied. Here you can see m cross n and n cross p. So n is common here, that's why we are able to multiply AB, and AB is of final order m cross p. But here in the example, as here given 2 cross 3 and 2 cross 2, AB cannot be multiplied. If you see A and C can be multiplied, and the result will be of order 2 cross 2. Why? A has a order of 2 cross 3, and C has a order of 3 cross 2. So A has the 3 columns and C has the 3 rows. So you can multiply them because the number of columns of A equal to number of rows of C. So finally the AC matrix will be of order 2 cross 2. This is the very fundamental concept behind the matrix multiplication. Here you can see A and C can be multiplied and the result will be order of 2 cross 2. So let's multiply A and C. So for multiplication, we have to multiply row and column. See, I am multiplying 2 into 1, 2 into 1, 2. Then I will multiply -1 into 2. What is -1 into 2? -2. Here I have written -2. Then I will multiply 3 into -3. What is 3 into -3? -9. And I will write it in a single element. So 2 into 1, 2, -1 into 2, -2, 3 into -3, -9. Similarly, you can see for the first row and second column, means this row and this column. First row and second column, 2 into 0, 0, -1 into 1, -1, 3 into 5, 15. I have written here in one element. Similarly, you can do for the second row, for this row. So finally, the result will be this one, -9, 14 and -10, 21. So let's move on. Now multiply C and A. Before we have multiplied A and C, A matrix and C matrix we have multiplied. Now we want to multiply C and A. Let's see C and A are multiplicable or not. So you can see C is order of 3 cross 2 and A has the order of 2 cross 3. 2 rows, 3 columns. That's why 2 cross 3. So as for the matrix multiplication concept, we can say C and A are multiplicable because here 2 is the number of columns here and 2 is also here number of rows. So the result will be a 3 cross 3 matrix. As you can see here, C and A are multiplied. How will you multiply these two matrices? So will be multiplied with first column first. So 1 into 2, 2, 1 into 2, 2, and 0 into 0, 0. So 2 plus 0 equal to 2. Similarly, first row and second column. First row, second column, 1 into -1, -1, and 1 into 1. 1 into -1, -1, 0 into 1, 0. So -1 plus 0. Similarly, you can do for the other elements and it will be a 3 cross 3 matrix. You can see here. So again I am doing here the matrix multiplication. So it is 1, 0, 2, 1, -3, 5 multiplied with 2, -1, 3, 0, 1, 4. Let's do the multiplication. So first I will consider the first row and first column. So 1 into 2, 2 plus 0 into 0, 0. Then I will consider first row and second column. So 1 into -1, -1 plus 0 into 1, 0. Then I will consider the first row and the third column. So 1 into 3, 3, and 0 into 4, 0. Similarly, you can do for this row and this row. So you can find out the rest of the elements. Alright. So as you can see, A into C is not equal to C into A. A into C is not equal to C into A. So we can say matrix multiplication is not commutative. This is the very important property of matrix multiplication, is that A into C is not equal to C into A. So you can say multiplication of matrices is not commutative. So these are the some properties of matrix multiplication. As you have seen earlier, matrix multiplication is not commutative. Let's see the property of distributive over addition. What is the property? A into, these are the matrices, all are the matrices, A, B, C, all are matrices. So A into B plus C equal to AB plus AC. Simple. Then A plus B whole multiplied with C equal to AC plus BC. Next property, multiplication of matrices is associative. How? If A, B, C are suitable matrices meaning their orders are such so that they can be multiplied with one another, then AB into C equal to A into BC. This is the associative property. And the last property is, if lambda is a scalar, then lambda into AB equal to lambda A into B equal to A into lambda B. So these are some basic properties of matrix multiplication. If asked in objective question, we should be able to answer the questions. So moving on to the solution, we have to find what is the correct option. So if we multiply AC, we will get this. You can see 1 cross 2, 2 cross 1, so you can multiply them. So A into A square minus AB. This is the matrix AC. BC, what is BC? BC is minus AB plus A square, or you can say A square minus AB. So AC and BC are equal. So AC equal to BC. I think this is one of the options, so it will be right. If we see CA is also multiplicable, because this is 2 cross 1 and this is 1 cross 2. So the final answer will be a 2 cross 2 matrix. If you want to check, you can check. And CB also multiplicable. This is 2 cross 1 and this is 1 cross 2. So this is the matrix 2 cross 2 matrix CB. So if we compare the elements of CA and CB, these are not equal. So the final answer will be AC equal to BC. So this option is matching. So this is the right answer. Let's see the next question. Here A is given 4x plus 2, 2x minus 3, x plus 1 is symmetric. Then x is equal to, what is the value of x if this matrix is symmetric? So first we need to see what is the concept behind symmetric matrix. Then we will solve this problem. What is the symmetric matrix? If A is a symmetric matrix, then A transpose equal to A. This is the property. A transpose equal to A. A transpose equal to A means Aij equal to Aj for all I, j. Suppose for example A is equal to 1 2 2 1, and A transpose equal to, transpose is nothing but change column to row and row to column. So this row is changed to this column and this row is changed to this column. 1 2 1 2 2 1 2 1. So here these matrices are coming as equal, so you can say A transpose equal to A. So A is a symmetric matrix. Fine. So transpose means change row columns to row and rows to column. Example, Z equal to alpha beta. This is a 1 cross 2 matrix, and Z transpose will be, the rows will be converted to column. So it will be a 2 cross 1 matrix. This is the simple concept behind the transpose. So what is symmetric matrix? Symmetric matrix is nothing but A transpose equal to A. Now we will see what is skew symmetric matrix. What is skew symmetric matrix? Skew symmetric matrix, this is the condition, A transpose equal to minus A. A transpose equal to minus A. For symmetric matrix, we have seen A transpose equal to A, and for skew symmetric matrix, A transpose equal to minus of A. For example, if this is a matrix C, C is equal to 0 1 minus 1 0, if you take the transpose, so this row will come to this column and this row will come to this column. So you can see it is coming as negative of C. So C is here given. We know that negative of C will, what will be negative of C? So negative of C will be, minus will be multiplied with each and every element of the matrix. So 0, minus 1, 1 and 0. This is the minus C. After transposing the matrix, we are getting minus C. So you can say C transpose equal to minus C. C transpose equal to minus C. So C is a skew symmetric matrix. So coming to the solution of the question, here A is given as a symmetric matrix. So as you saw earlier, for symmetric matrix, A transpose equal to A, we need to transpose this matrix. So first row will be written as first column and the second row will be written as the second column. So we have to simply write it, write what is A transpose. Then it is saying that it is a symmetric matrix, so A transpose equal to A. So we have to equal those elements. So 4 is already 4, here it is written. Then x plus 2 equal to 2x plus 3. So you can write x plus 2 equal to 2x plus 2x minus 3. So x plus 2 equal to 2x minus 3. So if you solve this, x equal to 5 will get. So 5 will be the answer. 5 will be the answer. Here B option is matching, so 5 will be the answer. So next question, the inverse of the matrix, here matrix is given as 3 plus 2i, where I is root over of minus 1. 3 plus 2i, I minus I, 3 minus 2i. It is asking to find the inverse of this matrix, and these are the options. So we will solve this problem first, then we'll go to the concept of inverse of the matrix. So how to find the inverse of a matrix? This is the formula. A inverse equal to adjoint of A divided by determinant. Adjoint divided by determinant is nothing but inverse. This is the formula and we have to remember it. Adjoint divided by determinant. And how to find the adjoint matrix? Adjoint is nothing but cofactor of A matrix, the transpose of cofactor matrix. As we have seen earlier, what is cofactor matrix? If you transpose the cofactor matrix, you will get the adjoint matrix. First find cofactor matrix, then transpose it, then find the adjoint matrix, then find the determinant, then find the inverse. This is the step to find the inverse. So here we have found the first cofactor matrix. The cofactor matrix is nothing but, as you have seen, cofactor equal to nothing but minor plus sign, minor with signs. So find out minor and apply the signs. So this is what we get, the cofactor matrix. And for adjoint, we have to transfer the cofactor matrix. Here we have got the adjoint matrix. Then we have found the determinant of the matrix. The determinant is 12. We have found the determinant. 3 minus 2i is multiplied with 3 plus 2i is multiplied with 3 minus 2i, which is 9, minus of I into I. I into I is equal to I square. I into I is equal to I square equal to minus 1, and I into minus I is equal to plus 1. So I into minus I is equal to plus 1, and you take the minus sign, then it will be minus 1. So if so 3 plus 2i into 3 minus 2i is 9 plus 4 13 minus 1 equal to 12. So as per the formula of inverse, A inverse equal to adjoint of A divided by determinant of A. So this will be the answer. 1 by 12, 3 minus 2i minus I 3 plus 12 is the answer. So as you can see, the B option is matching. So this will be the answer. So to find the inverse, we have to find first the cofactor. Then we have to transpose it, cofactor transpose, which is equal to adjoint. Then we have to divide by determinant, and that is equal to inverse. These are the steps we have to follow. So let's come to the concept of inverse of a matrix. How to find the inverse of a matrix? The inverse of a matrix A, exists if A is non-singular. Non-singular means we have seen determinant of A not equal to 0, and is given by the formula A inverse equal to adjoint of A divided by determinant of A. If determinant equal to 0, then this term will be in the denominator 0 will come, so the value will be infinite. So A inverse will not exist. So it is necessary that A should be non-singular. Again, this is a property. Inverse of a matrix is always unique. So how to find the adjoint of a square matrix? Adjoint of a matrix is calculated as transpose of cofactor matrix. Suppose the example A, B, here is the matrix given A, B, C, D. To find the cofactor matrix, we know that cofactor is nothing but minor plus signs. First find minor and apply the signs. So this is the matrix we will get. Then for the adjoint matrix, transpose the cofactor matrix. Row, column, row, column. So this is the transpose. Then finally you get the adjoint matrix. Then what is the inverse? You have to divide adjoint by the determinant value, AD minus BC. So here is the final expression. You can remember it as standard formula. ABCD, inverse of ABCD matrix equal to D minus B minus CA divided by AD minus BC. This is the standard formula also. You can remember it to quickly find the inverse of the matrix. Coming to the next question, it is asking A multiplied by adjoint of A will result in dash. These are the options: determinant of A, or determinant of A into identity matrix I, or only I, or A square. Which is correct? Let's see. So first let's take the example as A equal to ABCD. So adjoint will be D minus B minus CA. So let's multiply A and adjoint A. So first row will be multiplied with first column. You can see AD minus BC. Then first row will be multiplied with second column. So minus AB plus AB. Similarly, the rest of the elements can be found out. So you can see the final matrix will come as this matrix. So if you take AD minus BC common, out of the matrix, then what will remain? AD minus BC into 1 0 0 1. 1 0 0 1 nothing but the identity matrix. So this is the final answer. It is also a standard formula that A into adjoint A is nothing but determinant of A into identity matrix. You can remember it. So the answer is determinant A into identity matrix. So B option will be the answer. So let's see what is the next question. Which of the following statements are not correct? These are the statements given. We have to find which is not correct. So first statement is saying inverse of a square matrix, if it exists, is unique. It seems correct, as we have seen earlier. Inverse of a matrix is always unique, so it is correct. And these are the statements, and options are these. So let's see the solution. We saw before that inverse of a square matrix is unique, so this statement is right. And coming to the second statement, it is saying AB inverse equal to A inverse B inverse. AB inverse equal to always B inverse A inverse. This is also a standard property. AB inverse equal to B inverse A inverse. So in the option it is saying that A inverse B inverse, so it is not correct. So B option is wrong. You can check by taking the example also. If you take the example as A is this, B is this, if you want to find out the A transpose, for the next statement you can check A transpose, the transpose of A transpose, which is A. So the third statement is also correct. If you want to find out the AB transpose, the AB transpose will come as B transpose A transpose. You can check by multiplying these values, B transpose A transpose. So this is again correct. And finally it is saying A plus A transpose divided by 2 is a symmetric matrix. So let's A is this, as we have taken this matrix A and we have found A transpose equal to this. So let's see what is coming as A plus A transpose by 2. The matrix will come as 2 4 4 9, 2 4 4 9. So what is symmetric? Symmetric means A transpose equal to A. So row will be column and column will be row. If you want to find out the transpose of this matrix 2 4 4 9, first write the first row as first column 2 4. Write the second row as second column 4 9. Compare the two matrices and those are same or not? Yes, those are same. So A transpose equal to A. That's why this is the symmetric matrix. This is also a standard formula that A plus A transpose divided by 2 is always a symmetric matrix. So the answer will be only B option is wrong. This is wrong. It is asking which statement is not correct, so this option is wrong. So answer will be this option. So what concept did we discuss today? We saw how we multiply two matrices. We saw matrix multiplication, and we saw some properties of matrix multiplication such that matrix multiplication is not commutative. AB is not equal to BA, and we saw other properties of matrix multiplication, and we saw what is symmetric matrix, what is skew symmetric matrix. Symmetric matrix is equal to A transpose equal to A. Symmetric matrix is A transpose equal to A. What is skew symmetric matrix? A transpose equal to minus A. This is the skew symmetric matrix. Then we saw how to find the inverse of a matrix. How to find the inverse of a matrix? A inverse equal to, first find adjoint of A, then divided by determinant of A. Then we saw how to find adjoint of a matrix. How to find adjoint of a matrix? Adjoint equal to transpose of cofactor matrix. These are the concepts we discussed today. So that's for today. See you in next video. Take care.